Okay, welcome to Khan Academy. So today we're doing a least common multiple. So, sorry. So we have the least common multiple. Now, before we get to the common multiple, let's do just the multiple. What's a multiple of a number? What's a multiple of a second number? And maybe we could get a list of both numbers. So then we can compare two lists and get the common number. Because it's already a lot to unpack here. What's the least common multiple? Right? I mean, it's simple. You have 18. First, oh no, the example was 36 and 12. And the least common multiple is, because you see it, is 36. But it's just, yeah. Okay, so function to generate a multiples of a number. This function will generate an infinite list of multiples of a given number using list comprehensions. We can use list comprehensions. We make an infinite list and we can take, for example, with the function take, we can take a couple of numbers. And then the function will compare two lists of multiples and find the first common multiple, which will be the LCM. Oh, the least common multiple is a one number. It's not a list of numbers. The first common one. Let's implement these functions step by step using lambdas and list comprehensions. So the function multiples, it generates an infinite list of multiples of a given number. Multiples has a type, is a function from an integer to a list of integers. Do I write this? Multiples, integer to integers, to a list of integers, multiples. Wait, I want the arrow. Why don't I have the arrow? Wait a second. Preferences. I changed to GNOME. I don't like it so far. I mean, I like it, but it's... Yeah. Oh, it's still like this. It's good, yeah. Yeah, I'll do this. Variable not in scope. Multiples. But I'm declaring a type. Probably I cannot declare a type in the interpreter. Multiples. So multiples n. Oh, is n times n. Multiples of n. Multiples of a number is n times x. Oh, n times x. Well, what is the x? Oh, the x is a list of one. Oh, in x it goes an infinite list. So multiples of a number is a function that multiplies of, let's say, multiples of 10. So 10 times x, and x is a list of 1 to 100. But then I will get an infinite list. Function to compare two lists. What if I do this? Let's say take 8 of multiples of 10. Oh, okay. Multiples n times x, take 8 multiples of 10 times x. because if we just do this, yeah, we just get interrupted. Yeah. So we would have to take 8. Can we do like a dot? No, I cannot. Multiples, take 20. Okay, multiples of 8. 8, 16, 24, 32. All right. What? How we did? I like this. Yeah. Multiples and take 2, 20. Let's say like this. Multiples of 8. Copy. So this is evaluating expressions with 2 variables. Let's edit this file. Least common linear equations for both sides. Least common multiple. So that's Haskell again. Okay. So like this. So we have one list. That's multiples of n. We have actually a general function, right? We could take 20 of multiples of 8. So when he says what is the least common multiple of 36 and 12? So we could take of multiples of 36 and then 12. Right. So the least common one is 36. 36 and 12. That's the least. Now we have to have a function that would compare the two multiples. Yeah, I'm not sure how you would do that. Function to compare two lists of multiples. Here is the function common multiple that compares two lists of multiples and finds the first common multiple. So the common multiple x's and y's. So it compares two lists. Okay, that makes sense. So common mult. I'll just call it common mult. X's and y's is what? Maybe I could put this like a little smaller. X's and y's. Common mult of first list and second list. Okay. The head, you take out the head because you want to take the first X goes this list. Oh, the Y goes this list. This generator, and X should be equal. Oh, again with the predicates. Okay, so we want to compare two lists, right? And the predicate is, okay, we compare two lists. But why cannot we just compare two lists? What's going to happen? Yeah. Okay, because head of the X. Okay, and the X goes the X's, goes the first list, and the Y goes the second list. And the predicate is X is equal to Y. So wait, if I have a common mult, let's say 12 and 24, and the second list is 12 and 36, so I get 12. Yeah, but how does this work? Now we can combine these functions to find the LCM of two numbers using list comprehensions. LCM using multiples of a, b, common multiple, multiples of a, and multiples of b. Oh, now we are using common mult. Common mult. Oh, you can use like common mult. We already defined the multiples. Common mult of multiples of 12 and 36. And then multiples of 36. What's going on? Common multiples. Oh, I think it's just calculating. Ooh. Wait a second. Okay. So, you know, this has three parts. We need a function that makes a multiple of a number, right? We need two of those functions, but it's the same function. Then we need a function that will compare those two numbers, compare those two lists of those two numbers. And then we need a function that will, like ChatGPT wrote, here's the complete code. Okay, right, but there's a function. Multiples of n times x. X is the infinite list, right? So the multiples of 6. But if I just write this, I need to write, take 5 of multiples of 6. I get these multiples. So how would I take 5? Yeah, if I just do multiples, I'll have an infinite list. Like the common multiple, how does it compare? The common multiple of this list and the second list, of the first list and the second list, is what? Is the head. The head means just the first element of the list. Of the first list, the x and the y. But how does the x needs to be? Yeah, I'm not sure what's going on here. Like how does how does the head take out one number from two lists? You're correct that common multiple function is defined is not the most efficient way to find the LCM, and indeed can be confusing how head works with the list comprehension involving two lists. The approach of generating all pairs and then finding the first match can be inefficient due to the Cartesian product of the two lists. There's a Cartesian product. We can improve common multiple by finding the smallest element in the intersection of the two lists. Wow, here's the revised approach. We can use a more efficient algorithm that steps through the multiples concurrently rather than generating the full Cartesian product. This way we avoid generating unnecessary elements and improve performance. Yeah, but we're first looking for a simple solution. Oh, these are guards now. Let's revise the common multiple function to step through the multiples and find the intersection. Okay, we have a multiples. Let's see how we did this. We have multiples n times x. X takes an infinite list, right? N times x. Like you have a 2. Let's see. Multiples of 2. And let's just take 2 out of that list. 2 and 4. Multiples of 2. So it's an interesting thing. If you just write multiples of 2, you get an infinite list. Multiples of 2, 2 times an infinite list. So almost like you get a second infinite list. Like this infinite list is 1 up to, and well, look, maybe we didn't. If we have like, let's say finite mult of n is an x. No, finite mult of n is an n times x, right? And x will take what? X will take a finite list of 1 up to 100. Let's stop with that. Now it's fine. Now it's finite mult of 2. We get all the multiples up to 200. We get all the multiples up to 800, which is 2, 4, 6, 8. We get even numbers. Finite mult of 30, 3000. Okay, so we get the finite. So we could basically go up to a multiple of 100. So that will be the top one multiple, and we get 10,000. 100, 200, 300, 400. And we can even map this, like map finite mult to a list of numbers up to 10. Check this out. Isn't this cool? So we just mapped the finite mult, which returns the multiples of all the numbers from 1 to 100, right? But we mapped it onto 1 and 10. So we get 1. So we get all the multiples. Yeah, interesting. Function to generate multiples of a number. So function to find the first common element in 2 sorted lists. That's a lot. We have common and sorted. Not sure if this is already, maybe it's too soon to write it like this. These are guards. Common multiple. Now it's taking a tuple, x, 2 pairs, x and x's and y and y's. So x, these are predicates that have to be satisfied. So x should be the same as y, which would output x. X should be, if x is less than y. Oh, this is recursion now already. So if x is less than y, oh, this is already doing the calculation itself. So first, yes, it was not efficient because we generate the list. This is better, I think, for the beginner, because we generate the list like this. We generate 2 lists, and then we take a function that compares. And this is more efficient because we already set the predicates. And the predicate here is if x is less than y. If x is same as y, then output x, and that's the common one, the common multiple. So wait, we don't even need the multiples here, I guess. If x is less than y, then common multiple x's, y of y's. Yeah, I don't understand this. Otherwise, common multiple x, x's, y, y's. Yeah. These are guards. Now explain this. Let's see how it's, let's break down the common multiple. So first, the function signature. So the common multiple is a function that takes a list of integers and returns a function that takes a list of integers and returns an integer. Okay, we'll learn how to say that. It's important to learn how to say that. So this function takes 2 lists, or you can say this function takes 2 lists of integers and returns a single integer, which is the first common element in both lists. So function definition, common multiple. So common multiple of x's and y. Why are the tuples here? Explanation. Let's see the explanation. The pattern matching. So these are two tuples, are patterns that match a list with at least one element. X and Y are heads, first elements of the list. X's and Y's are the tails, the rest of the lists. So these are lists, but I thought these are tuples. X's and Y's are the tails, the rest of the lists. Guard clauses. Okay. X equals to Y is X. If the heads of both lists are equal, we have found the first common element. The function returns this element. That's clear. If the head of the first list X is less than the head of the second list Y, then the first list needs to catch up. If the is less than the head of the second, yeah. So that's like finite mult of 12, finite mult of 4. Oh, this is outputting always. No, let's do our take 2 multiples, take 6 multiples of 2 and take 6 multiples of 3. So okay, let's say we have two lists. Wait, let's do it like this. Okay, let's try it like this. If the head of the first list X is less than the head of the second list Y, then the first list needs to catch up. So the head of the first list is 3 or 2, and the head of the is 3. It needs to catch up. Otherwise, wait, if the head of the first list X is less than the head of the second list Y. So let's say the first list is this, and the head is greater than the head of the second list. Then we skip this, we go to this. If the head of the first list X is greater than the head of the second list Y, that's our case, then the second list needs to catch up. Yes, then this list needs to catch up. We recursively call common multiple with the entire first list and then tail of the second list. This effectively discards Y and moves to the next element in the second list. This is the part. Yeah, we recursively call common multiple with the entire first list. So it's almost like we compare it again. We recursively call how it works. If the head of the first list is equal to Y, head of the second list, return X because it is the first common. Okay, that's clear. That's just if like, let's say the head is like 12. And if it's here 12, then it just returns 12. That's common. If X is less than Y, discard X and move to the next element in the first list, keeping the second list unchanged. So if this is less than, yeah, but it's not less. Let's say this was the first list, all right. Let's say this is now the first list. It's less than 3. Discard X, all right, we discard this and move to the next element in the list. That's 4. If 4 is less, no, it's not. It's greater, then it means we go here. If X is greater than Y, discard Y and move to the next element in the second list. Oh, then we discard this and then we move to the next. I get it, and we move to the next. Now, if this is lesser than this, we discard this and we move to the next. If this is equal than this, if 6 is equal than 6, we got it. It's 6. Oh, that's how it works. Repeat the process with the updated list until a common element is found. Wow. Let's walk through an example to see how it works in practice. Find the LCM of 4 and 6. Multiples of 4. Okay, let's take 10 multiples of 4. And multiples of 6. Take 10 multiples of 6. So compare 4 from the first list with 6 from the second list. 4 less things, so discard 4. This is good. Example walkthrough. I'll have to copy this. Does the first comment, which is also finds the list count by finding the first common element of infinite list of multiples, leveraging the sorted nature of these lists. I should copy this. Linear equations. Least common multiples. Example walkthrough. So this generates a list of multiples. Here is an example. Here is a more general example. So, example walkthrough. No, this will probably not look good. Maybe not bad. So what's the code? Is this the only function I need? Common multiple. Is the common multiple only function I need? Let's see multiples and being used. Because I don't see the multiples and being used. The function common multiple directly compares elements from two lists of multiples, but it needs these lists to be generated first. Therefore, you still need the multiples function to create the lists of multiples for each number. Here's a complete and clear version of how you can use both functions. So you have the multiples. Multiples n. But where is the function being used? Oh, it needs... Yeah, it needs to generate it. Function to find the LCM of two numbers using the multiples and common multiple. Common multiple. Load the functions into GACR. Well, let's try this, actually. Let's see how it works. I'll do quit. It crashed again. I don't like this. I really don't like this. Second time it crashed. HX. Horrible. HX. Least common LCM HX. Multiple. Just a moment. So let's see again. Function to generate multiples, common multiple. This looks fine. So if we load this, load LCM, one moment. So how would this work now? So you would load it, call the LCM using multiples. LCM using multiples, A and B. So LCM using multiples of 12 and 36. 36. LCM using multiples of 8 and 73. 584. This is cool. 9 and 813. 2439. So this is nice. This is a good function. It just takes time to really parse these things in your head. Like I've used ChatGPT, but it's still multiples, integer, so multiples of n. We generate the list. Yeah, it's the common multiple. LCM using multiples. Common multiple. It's just, for me, it's not clear why is the tuple. Well, this defines a list. Like, but you mentioned lists, but then there is a tuple here. I see the confusion. The notation x, x's, and y, y's is Haskell's way of pattern matching to destructure lists, not tuples. Ah, here's a more detailed explanation to clear things up. So yes, it's understanding pattern matching. So x axis is a pattern that matches a non-empty list. X is the head first and axis is the tail. So it's a non-empty list, or is it an empty list? So it could be an empty. So the function to generate multiples of a number. The multiples function generates an infinite list of multiples of a given number. This means for n12, multiples 12 will generate 12, 24, 36, 48, blah, blah. So the common multiple function finds the first common element between two lists. Matches the first list where x is the head and x is the tail. Matches the second list where y is the head and y is the tail. Now guard clauses. X equals to y is x. If heads of both lists are equal, we have found the first common multiple. If x is less than y, then common multiple x is y of y's. So this is, yeah, I think this is confusing. It's because it's recursion. It would be nice. I want to make a more simple, yeah, discard and move. So yeah, so this introduces recursion. Can we introduce this concept like here, but in a even smaller and simpler terms, so that we can use it and see how it works? Okay, simple recursion, sum of a list. Let's start with a simple example, calculating the sum of a list of integers using recursion. Sum, that's the sum of x and x's. The base case, the sum of an empty list is 0. Sum list. Base case, the sum of an empty list is 0. The sum list x axis, x plus sum list of the rest. Recursive case, add the head of the list to the sum of the tail. Okay, yes, this makes sense. So sum list 1, 2, 3, 4, this will return a 10. Sum list 1, 2, 3, 4 and an empty list becomes 1 plus sum list 2, 3, 4. 1 plus some list 2, 3, 4 becomes 1. Yeah, this is nice. Simple recursive example, finding the first common element. Let's use recursion to find the first common element into sorted lists, similar to what common multiple does, but on a simple level. This is nice also. First common of two lists. If x, first common of two lists. First common of two lists. This will return just 3. Oh, we could use that, first common. So first common of x and x's and y and y's. If x is equal then y, then just x. Maybe integer. Oh, this is using a maybe. This is a monad. Okay. Well, okay. If x is equal to y, so this is comparing. So all of this stuff, what we've been doing now, it's comparing things. This is where things become a little bit more complicated. If x is same as y, so if x is same, so if the first element of the list, of the first list, is same as the first element of the second list, then just give me the x, because it's the same as the y. It could be y also. If x is less than y, then the first common of the list compare, oh, then the first common of the list of the x's. Oh, then compare the first common of the tail. So if the first is less than the y, if the first is less than the y, then compare the first common. Okay, then compare the tail of the list. So if our list is 1, 2, 3, 4, 5. If our list is 1, 2, 3, 4, 5, and here is 1, 2, 3, 4, 5. So, and here is 2, 2, 3, 4, 5, 6. So if the first one is less than the 2, then compare the tail of the list, which is 2, 3, 4, 5, 6, with the rest of the list. Then it's 2. Then the x will be same as y, and we'll get the x, which is 2. Otherwise, first common if it's lesser or greater, right? Otherwise, first common x's compare with the y's. First common, nothing in case one of the list is empty. So this is interesting also. This is something to think about. Okay, this kind of, this recording is a bit, you know, maybe not so, you know. Let's see a more simpler or smaller example of comparing common numbers from two lists. Haskell. So this introduces a maybe. Can we do this without the maybe? Yeah, this is without the maybe. Integer, without the maybe. And without the maybe. So the first common, if x is same as y, yeah, I'm over repeating myself, I guess, which makes it pretty boring. But I don't know, it's hard to compare. Like, you have two things. You compare the first and the second. But I think this kind of thinking is very sequential still, because you do have a list of things. So you first compare with the two things which are in front of you. If this is the same as this, is the same, give me that. That's the common thing. That's the common thing. Otherwise, if this is smaller than this, well, let's throw this away and check if this is the same as this, right? First common. So let's compare it again with the tail. This is the tail. Let's compare now the tail. So it's just we have to label things in programming. I think we have to label things. So we throw out the list, right? We have two lists, right? We have 1, 2, 3, 4, 5. And let's say we have 2, 3, 4, 5, 6. So give me the first list and the second. We compare 1 and 2. Boom, not the same. Is it less or is it greater than 2? It's less than 2, right? Then comes this first. If it's less than 2, then compare the tail of the list, which is the rest, which is this, with this list, and then we'll see that 2 is same as 2. What do we get now? Now it's like another process. Again, we're comparing. Okay, x is same as y. So the first part of the tail of the list is 2, right? Because if you have a list, right? If you have a list, 1, 2, 3, 4, 5, so the head of this list is 1. But if I discard the 1, right? Like, if I discard the 1, and now I have, like, my new list is now 2, 3, 4, 5. So if I do a head of a new list, I get 2, right? So otherwise, if it's greater than this, if I have, like, let's say my left hand 3 and I have here 2, then I discard this number, right? I take the rest, I compare this list again. That's why here is x and x's. So I compare the entire list with the tail. So this is actually very intuitive. I think it's just this. I've been talking about this way too long. It's very intuitive, but it's when you start to visualize these things, it may seem complicated, right? I kind of like this example now. First common x, x's, y, y's. First common y. First common x, x's, otherwise. Integer, integer, integer. First common is a function. First common is a type of a function. So what's first common? Wait, let's quit. Let's write first common. So first common integer that is a function that returns an a function. It's integer. No, I'm still not sure about integer. But it returns a number. It takes a list and returns a function that takes another list and returns an integer, right? First common. Why is there the type signature lacks an accompanying binding? All right. First common. Yeah, first common. I think it's fine now. Undefined. Now it's fine. Right. Imported from prelude, undefined function. Undefined. So first common, x, x's, and y, y's. So the first common will take two lists, x then non-empty lists that have the first part and the second part and the tail. The first part and the tail, right? Now, we're going to put some guards. We're going to pattern match. So, if the first part of if the head of the first list is same as the head of the second list, well, then you just give me the x. Otherwise, if x is smaller or lesser than y, so if the head of the first list is lesser than y, not than y, but it's lesser than the head of the second list, then what do we do then? Well, we have to repeat the process again. The first common, right? We're going to compare the rest of the first list again with what? Oh, we're going to compare the rest, so the tail of the first list, because the x is smaller than y. We're going to compare the tail of the first list with the entire second list. And the entire second list, this doesn't look good with helix. And with the entire second list is y has, this means that this is the entire list. And this is the tail, because the first is less. The head of the first list is less than the head of the second. Otherwise, it's just the opposite. If x is greater than y, then we do, again, we compare. Now we carry the y, right? The rest with what? But I guess maybe it's better to write like, so if the head of the first list is greater than the head of the second list, then we should compare what? We should compare if it's greater than the second. Then we need more numbers in the second. So we need to discard something from the second list to get to the first list, right? So we're going to compare the entire first list, x's, and we're going to compare it with the y's, with the rest of the second list. Exactly. So if I quit now, go to GCI, load first common, load the first common, and now I'm going to first common. What? I need two lists. So I will have to input two lists. We could do this actually. First common, multiples of n. We could give the list. Okay, let's make it like this. 1, 1. Let's do like this. 1, 2, 3, 4, 5. Right, and the second list 2, 3, 4, 5, 6. So the first common, it's 2. Yeah, this works. The first common, pattern matching. Example walkthrough. Compare A, compare 12. So the first element, right? Combining with multiples. We can use this function to find the LCM of two numbers by generating their multiples and then finding the first common multiple. Oh, so that's how we use, yeah, because of course we are talking about the first common of any type of list. You can use the multiples and you will use the first common multiple. All right, this was kind of interesting, a bit intense for me. All right, thanks.